Next presentation is by Nitin Malhotra from Amplify Health. He heads the business development and growth for Amplify Health. Nitin has been in health technology and analytics organization. Amplify Health is a health technology and analytics organization focused on empowering payers and providers across Asia. With strong foundation of growth strategy and ecosystem building, he works to forge partnerships, expand market research, reach, and translate data-driven health solution. Over to you, Nitin.
Thank you so much for the kind introduction. Sorry, I'm just looking for the clicker. He just needs to put it up. Okay. So hello everyone. Today I'll be talking about claims, mainly in the health insurance space. So we are Amplify Health. We're a company set up by AIA and Discovery/Vitality. We're a corporate venture. We're based out of Singapore with offices in Hong Kong and soon to have an office in India as well. We basically focus on claims transformation, everything from adjudication, straight through processing, and fraud-based abuse in health insurance. So we are prevalent in the Asia market. We are venturing into other geographies as well. Hence, we are here. We have a booth as well. So feel free to visit our booth as well. And we have a panel session coming up at 5:50 as well. So we're a tech stack based on data. So what you see at the bottom is basically our target health data model that we've built based on our parent heritage from AIA and Discovery. We have about 20 plus years of data that we've modeled for health insurance. And on top of that, we've built our products. So our products are based from clinical informatics to business intelligence to provider management, core claims, which is straight through processing, adjudication, and then of course our smart claims module, which is our fraud-based and abuse. We also have white labeled Vitality, which is a wellness app, as well as a chronic disease management, which is more in the B2C space. So yeah, we are modular, we are flexible, and we kind of, can plug and play into the journey that you're undertaking in the health claims insurance space. We basically set ourselves on power. Our products based on data and member health. Today's focus is going to be on our payment integrity or smart claims. So where we're going to be looking at fraud-based abuse, and it's powered by our clinical encoding, which is basically enriching your data. So I'm going to focus on a few areas for the demo. So we're going to look at line level intelligence, member longitudinal analysis, as well as collusion detection. We will go into a little depth. If you want to find out more, definitely please stop by our booth and we'll be happy to elaborate further. So without further ado, let me jump into the demo. So what you see here is you've logged in as a claims assessor into our fraud-based abuse module, which we call Smart Claims. So this kind of represents the view that would you get once you log in, right? And before we get into the claims details, we'll see that we are powered by two engines. One is the AI-driven FWA engine, as well as the AI-driven decision engine. So now if we double-click into a claim, right, what you'll see is on the left, you see all the details about the claim, and on the right, you'll see how our decision engines are working. So for example, for the AI-driven FWA engine, on the right, you could see the FWA reasons, where we talked about the cost per item, quantity per item, and of course the non-payable items. And now what you see is the AI decision, which is talking about, based on historical data, how this claim came in, and if it should be flagged as an outlier or not. Yeah. So basically our engine is saying that, you should look at it, we are approving it from a machine, but based on the business rules and FWA, you should definitely review it. So overall, what you see in our smart claims Gen AI architecture is enabling the right claim for the right person in the right amount. It takes, basically your business beyond statistical likelihoods and simple outlier detection into more details. Yeah. So now if we actually click onto the line level details, what we see is, there are many categories that we have actually seen where this can be caught. And we focus on two categories here. One is ethical and the other one is surgical. So in ethical, you basically see that a couple of these medications that were given, this is a claim that we've put into one of our deployments in Hong Kong. And what you see is there are a couple that the cost per item is way higher, and also the quantity is actually way higher than what we would expect. Yeah. So now what we want to see is kind of what is driving this higher cost. On this next section, if you scroll, you will basically see the one that I'm going to show you is surgical, where you see that, we are looking at items or quantities that were flagged because they are unusual. So here we see an example of laparoscopic, where, we have used CO2 insufflator, which has been charged with 2 units, but we are aware that this should be part of the surgical surgery cost itself. Yeah. So we see that there are 3 units charged here, but for a general pack, which could be a gown, a table cover, a side drape, towel instruments, etc. But the model finds a requirement that, these 3 to be excessive, as we know that 1 pack is adequate. So the deviation basically calls this out. The next one you see here is, the surgical non-payable items, where we are seeing like a warming blanket that we know that is not covered under the benefits, and hence it's a non-payable item per the insurer's coverage list. So this section, what you see is basically we are explaining member suspicion. Yeah. So this is our view of the member suspicion model, which is looking at the longitudinal behavior over time, telling us whether a member shows outlier behavior and the potential reasons for it. So here you can see that, for example, we look at the red flags and you see 119 accident claims have been filed in a 1-year period. And it's also like 40x of higher than the peers. So what I'm trying to tell you here is if we start from the top left, which is the overall narrative, we're talking about a claim level where we're showing that there's very high volume, high cost claims. The claims are mainly accident related. They are non-panel. Many claims are submitted over weekends. And of course, there are repeat submissions. So now if we dive into each of these sections, we can see that the indicators are being shown. For example, the red flags. Now, this is the high utilization and the high accident frequency. Please note here, all this information is basically being obtained by running our Gen AI and LLMs in the background to add explainability and define a meaning to the outcomes the tool is throwing out. Yeah. So the next section we see is number 3 is hypothesis, where we're seeing that the flags could now mean is that duplicate billing is happening based on the extremely high repeat claim submissions. There could also be a possibility of non-panel gaming here, where all the claims are being serviced by non-panel providers. And there could also be inappropriate frequent billing, which is happening due to non-specific procedure descriptions. So this is just a sample of the points. Of course, each of these sections you can scroll down and there's more further detail that actually our module spits out. The next section, number 4, is looking at supporting evidence, where we see the evidence can be linked back to the hypotheses. So for example, a duplicate bill on the 29th of March, we see that 7 claim lines for a similar procedure tagged as other therapies and for the same diagnosis all amounted to a high paid amount. Now there's also evidence in this section against other hypotheses, which can then aid the claims assessor / investigator to able to go deeper into these assessments and determine what the findings are. Now, before I go into section 5 and 6, I want to give you some context. The previous sections kind of showed you the evidence that kind of working like, I would say, a prosecutor, whereas here the context is more about the responsible use of AI, where you want to ensure that we have multiple vantage points to see the same thing. So what the view provides is more context, where you could see that this could be a genuine, legit claim rather than being suspicious. So before you decide, so section number 5, we're talking about the scenario where it could be a young active, 26-year-old male with consistent accident sports injuries, right? And his individual plan permits him to go to non-panel providers because they might have trust for those providers and visit them repeatedly. Or they could be the best providers in that area, and they may happen to be non-panel. So the member is still choosing based on the provider they want. So it's a choice that they're making. The next one is more on the follow-up actions, where we are looking both at the indicators view and the contextual view. And a few recommended options are: A, immediate hold on all pending claims for this member, so that a review of the medical records takes place. B, audit the provider and the billing patterns. And C, interview member regarding rationale across various activities. So based on all these findings, you can make a decision on what next the actions could be. Now this last section is basically showing you how our collusion model works, where we're looking at 3 doctors, which is the referring. So we are looking at the anomalies, right, and the outliers at the claim level. And at the claim level, we can go one step deeper. So we look at the detection as to how the entities are interacting amongst each other. So in this specific example, what you see is we have rendered the referral patterns between the referring doctor, the treating doctor into a graph database, and looks to identify the certain closed loops that are being formed. This could be a representation of collusion. Then there is a dermatologist referring to a cardiologist and forming a closed loop. Now, the provider cannot perpetuate fraud in isolation. So of the multiple connections, these two form a closed loop and allow you to further investigate. Ultimately, this acts as a tool for the investigator or assessor to identify such loops and then investigate for possible collusion and control any anomalous payouts. So with this, I come to the end of my presentation. I'm happy to take any questions and answers from the audience, please. We still have a few minutes, right? Yeah. So I'd like to invite Dave, my colleague here, who's also the Chief Data Analytics Officer, to join me on stage, please. Any Q&A, or if you want, you can definitely drop by our booth. It's right at the end of the hall. Happy to elaborate more. If not, then thank you so much for your time, and I wish you a wonderful rest of the day.